A person stands in an elevator or lift. The total mass of the person and the elevator is 800 kilograms. The elevator accelerates upward at 2 meters per second squared. What is the tension in the cable? Choices are 1.6, 6.4, 8, or 9.6 kilonewtons. We define up to be the positive direction, not because it's going up, but the acceleration is up. We actually don't know whether the elevator is going up or down. We draw a simple free body diagram with tension greater than weight, so the net force is equal to their difference. Weight is mg. There's a shortcut in this particular problem. We can use 800 for m and 10 for g for a weight of 8,000 newtons, or 8 kilonewtons. We know tension has to be greater than weight in order to accelerate up, and there's only one choice greater than 8 kilonewtons. The more systematic method is to actually find this value. This requires Newton's second law. We solve for tension in terms of the net force and weight. We put numbers in and get 9,600 newtons, or 9.6 kilonewtons. Process of elimination should only be used when you have good reasons. Doesn't seem right, or too many C's in a row are not sufficient. If there's time at the end, be sure to go back and fully solve the problem to double check. This syllabus uses 9.8 for G, when previously it was 9.81. Multiple choice questions seem to continue to use 10.